Yo! Welcome back to the development diary of Umi, the new systems language that's inspired by C. Last time, we took a very deep dive into a not so deep topic, which was creating the BNF form for a basic function prototype. And this doesn't even include the body of a function. We got to the point where we need to parse an expression, and we stopped just short of defining that rule. So the objective today will be to write the expression rules, and we'll just go ahead and we'll start to define the rules for a general expression, which will include basic literals such as this number 3, put that there, this number 3 on my function variable function parameter, the default value of my function parameter, but we'll also go ahead and we'll define things for like addition, subtraction, multiplication, dereference, etc., etc. So, there's really nothing to do but to do it. So let's do it. So an expression is potentially a tertiary expression, and a tertiary expression is, what is a tertiary expression? Actually, I kind of dislike, well, do I dislike this? I was thinking of just having many rules on their expression. Since we're going to be handling the parsing of this ourselves and not using a generator, we could just go ahead and write what this is. I guess we'll just leave it like this. So a tertiary expression is going to be some kind of binary expression, and I want to have the like inline ternary expression in C++. So that involves this. So it's a binary expression followed by equals sign, question mark, followed by potentially a binary expression, followed by, no, I think this can just be a regular expression, or can it? Ooh, there's like I do remember from the last time that I implemented, it didn't implement, but I wrote a grammar for another language, and we had the same sort of expression syntax as C does. I am trying to recall whether or not I'm doing the same thing that I did there, but let's just go ahead with this, and we'll see where this leads us. If this happens to be broken beyond belief, then we'll fix it up there. But this is looking like it should. Maybe an expression is a tertiary expression or a binary expression. Or it's a unary expression, I guess. Or it's a primary expression, which is just the basic, which is like the leaf of this. All of these will be recursive, spoiler alert, but primary expression will be a terminal. Okay, I think that's all right. So a binary expression is going to be some kind of unary expression followed by one of our terminals. And this is where we'll have to start thinking about precedence eventually, but it can be, let's say it's going to be a plus or a minus or a times or a divide, or it could be a bitwise and. I'm trying to get this to be in the correct precedence as well. The question is, does binary and come before these? It very well might. So you know what we'll do? We'll actually put this as a separate thing. We'll call this binary op. And then followed by binary expression. So not optional. So this is one of those examples where, oh no, I don't, actually I think when we do this, we actually need to put it like this. No. It should be like this. Yep. Okay, so the reason why you do this is that every binary expression is a unary expression or it's a chaining of like more binary expressions. And the reason why you can have this is so if you think inside of this tertiary expression, if we didn't have the ability for a binary expression to be a unary expression by itself, then it would make every expression be. I guess you could just put this as expression, couldn't you? We'll think about that later. But for the time being, we're just going to do it like this. So every binary expression is a unary expression with maybe a binary op followed by another binary expression. And so this fits the case where we have like 1 plus 2, or we just have 1, or we could have like 1 divided by 3, etc., etc. So I guess here we'll also put binary op. Now, getting the precedence of the binary operators correct is extremely important. I just don't have on the top of my head what I want those to be, but I know that we want binary and, we know we'll want binary or, probably also want to have left shift, right shift. And these will, I guess, bind more strongly than, actually, maybe these will bind even stronger. I think people generally expect the shifts to have stronger binding than these operators. And here, there's also the modulus operator. Where is modulus? There you are. Of course, we'll also have our logical operators. So this will be and, or has lower precedence than and, I should say. But I think equals equals has higher precedence than both of them together. Can't get the alignment right. Stop. It's very annoying. Equals equals. And I guess with equals equals, we'll have the other relational operators, like not equals, less than, greater than, less than or equal, greater than or equal. Now, C++ in recent years has included a ternary operator, which is also known as the spaceship operator. Do we want to have that? I don't think it makes sense. I think them putting this operator into C++ anyway was a stupid idea. So I guess we're just going to get rid of it. So no, you don't exist. Yep. Cool. Now I know languages like Go, they actually introduced even another operator, which was like, I think it's like not and, something like this, or is it and not? It kind of looks like this. I'm gonna have to do more research into this, but maybe we want to have, if this can be implemented quickly in hardware, then we'll want to have an operator like this, or maybe it was like this, whatever the hell it was. We'll want to have that as well. But for right now, I think it's okay. I think we've covered most of the operators. Yeah. Can't quite tell if we're missing any of the... Oh, this caret. That's a bitwise operator, so you go here. This is for exclusive OR. And I do believe that is all that there are. So we'll continue with the assumption that this is all that there are. Okay. So following down the chain, we're also going to need to figure out what a unary expression is. And a unary expression, there's two kinds of unary expressions. There's the unary expressions where you have the unary op on the left. And then you also have a unary expression where you have the operation on the right. And I guess the way that we'll do this is we will do it such that we'll have a post unary expression. So there'll be a post. And a post unary expression is where we have a unary op or a post unary op, followed by a pre unary expression, and then a pre unary expression is where we'll have it. A primary expression followed by a pre, or sorry, this is the other way around, isn't it? This should be a pre unary expression, and you are post. Pre meaning before, post meaning after. Like this. Yes. Okay, cool. So we'll make the ops for that. So a pre-unary op. This is dereference, address of, not, and bitwise complement. These should all have the same precedence. And I think that might be it. For right now, anyway. Yep, I can't think of anything else. Okay, and a post unary op is that would be the array subscript operator, and we'll also have potentially the call operator as well, parentheses. And this is where we'll also have the reference member op, or we'll have the pointer member op. So this is like something dot something, and this will be something arrow, right arrow, something. So now we'll have to define these. As you can see, this starts to get, even just one basic thing, it starts to unravel the whole house of cards. So the subscript op starts with a right bracket, and then it has 0 or, well, it needs to have, I guess, maybe one or more expressions. So one or more expressions inside. I guess this is technically the same as our parameters up here, where we only have this case, but we either have an expression followed by a comma, and there's 0 more of these, and then the very last one has an expression and then an optional comma at the end. So it'll be the same thing. So this will be expression followed by a comma, and there's 0 more of these. And then finally we have expression followed by a comma, and that's optional. And then finally we have the closing bracket. And a call op is the same. But this time it starts with a left parens, it will close with a right parens. Here we'll have not just a regular expression, we will have an argument followed by a comma, and there will be 0 or more of these, followed by finally one argument and an optional comma at the end. And an argument is what you have with your girlfriend. No, an argument is either an expression or For us, it will be a named arg, or I guess we can just write it directly. So that'll be colon followed by an assignment. Expert. Yes. One more binary operator, which is very controversial for some people, is I also want the assignment operator to be able to be used in expressions in exactly the same way as it is in C, because I think it's cool. So if we were to put that inside of a argument expression, like how I showed before, did I delete the code? I did. If we had something like printf format equals, I want this to be able to have an expression like a equals 3, but this will be parsed as part of the like argument, the named argument call op thing, and this will be just a regular expression. So actually, I guess technically it could just be this followed by expression. So maybe that works actually. Followed by expr. Yeah. And we'll actually, I guess we'll preferentially take this as the first thing that we'll look for, followed by expression, because there is no expression that begins with a colon on its left-hand side. So that looks like this will work. All right, cool. Okay, so that's the next one is member op. And member op is a dot followed by an expression. Does that make sense? No, I think this would have to be an identifier. Wait, could you have that? No, because you wouldn't be able to have chaining of these. Although these may already chain. I'm going to go the safe route and just say it's identifier, and then we'll see if we can chain. We'll implement the parser with this in mind, and then we'll see if we can chain based on the way that we have written this. Because if you think about it, if it's member op dot identifier, when you have a binary expression, it will chain. But it has to chain with a unary op. But a post-unary op is also a primary expression followed by another post-unary op. So it looks like this would also chain. So maybe we only need to just say it's dot? Maybe? Because if it's primary expression, then dot. This would need to recur somehow. Primary expression, dot, how would it recurse if it was just dot? Maybe it can't. Definitely the chaining here is going to be broken the way I've written it now. For the purposes of this video, I think we'll leave it to be like this, and then in the next video, I'll come back. We'll come back and we'll fix this up, which would imply that also our pointer to member up will also be broken for the time being. But I don't want to get hung up on this breaking for right now, so we will fix this up in the next episode. Okay. And then finally, the last thing that we'll add in is a primary expression. And the primary expression can be, this is where things get a little crazy. So, for example, we could have an integer literal, a floating point literal, a string literal, or we could have this. Float literal. Well, this isn't even integer literal. This is like a decimal literal. Decimal literal. But you could also have a hex literal. You could also have an octal literal, because sometimes octal is important. Or we could have a binary literal. Or we could have a float literal, or we could even have a hex float literal, which, yes, does exist. Or are there other kinds of literal? String literal, that was the other one. Or there's one more thing which I want to add in. So in C and C++, specifically the GNU strand of compilers, there's a very neat extension which exists. And that extension is you can have an expression like this, and you can be like 1 plus 2 plus 3. Sometimes, though, you have far more complex expressions, and you need to have some code that you can execute with statements and things like this. And so in GCC and Clang, you can create expressions that look like this. And you can say things like order result is equal to 1, and then maybe result plus equals. Yeah, the compound operators. We have to add those in for our binary operators as well. Or you could even do this. And the result of this expression is the final result of an expression statement, which is what this is known as, is the result of the final expression that is evaluated. So by just saying result here, the result of this expression will be result. As you can see, CLine has inferred that to be int. And this is how these work. But what's even cooler about this is that you can literally like put return statements on the inside. You can probably throw something if you wanted to. You could put if statements and other control statements if 1 equals 2, which it doesn't, things like this. So an expression statement really is a bunch of statements that will result into an expression. And they're very, very, very useful in places that you would least expect. So I, without a doubt, want to have expression statements. And so I don't know how we'll end up parsing this. Right now, this looks like it would be the same rule. I guess I can put statement here. So I want to eventually have this be what we're parsing. Obviously, now if we have statement inside of here, then I guess this would actually be block statement. we're basically going to define the entire grammar for the language just by writing out the basic code that we would need for parsing one of these, which I guess I want to avoid for right now. So we want to add this in, but we don't want to add this in right now. But we will have to define our literals. Before I do that, I need to also stick in our compound as operators before I forget. So plus equals, minus equals, times equals, and this is divide equals. I also want to put in, I don't know if you can do call equals. That wouldn't make sense. So I guess we won't do that. But there's also modulo equals. And there is also or equals. And these will be new operators to see to UMI that aren't in C and C++. I also want an or equals and an and equals, and that looks like all that we can put in for right now. But I also want to stick in down here and equals and or equals for when you're doing logical chaining. These operators, they don't exist in C and C++. Now, the precedence here might be a little busted. Not going to lie, could be busted. So we're going to have to check this when we go through implement the language. It could be that with the introduction of these new operators, we may need to figure out the precedence for ourselves and not have anything to reference. While I remember, also, we have... Please line up. Okay. There's also left, left, shift equals, and right, right, shift equals. Does it make sense? We unfortunately cannot have a greater than or less than because those tokens are already taken. Also, it would not make sense. So these relational operators will stay the same. But these won't. These will be different. So that seems good to me. So a string literal, we'll have to potentially leave off the literal creation of the literal rules for another episode because string literals will include things like escape sequences inside of the literal strings itself. But at least for a decimal literal, we can get a taste of what this looks like right now. So a decimal literal will optionally have an OD for whatever reason, right? It's so weird. I just don't understand what the committee was thinking or not thinking when they made this. They made OX for hex. They made O0 or O for octal. They made OB for binary. But they don't have an OD for decimal, which is like, why? Because sometimes you have mixed base characters or mixed base numbers in the same code. Sometimes it's more convenient to look at the code in binary or a number in binary. Sometimes it's more convenient to look at it in octal. Sometimes much more convenient in hexadecimal. And you just want the numbers to line up. And so you don't want to have to put in decimal with nothing. Like if you have nothing, just default it to be decimal. But otherwise, let us put a prefix in. Like you don't. Why does this not exist? No idea. But it doesn't. Until now. We'll make it exist. But it's optional. So a decimal literal is an optional OD followed by the characters 0 to 9. More than one. And even a hex literal, we should be able to write hex literal as well. Hex literal is not too difficult. A hex literal is OX, which is now not optional, followed by 0 to 9, or A to F, or A to F. Looking at this, if we had the number 0 here, we would have an issue because 0 is shared amongst all of these things. So I think with our primary expression, we'll add in one more rule, which will match, and it will be 0. And the 0 rule will be literally just number 0. But if 0 does not match, then it has to match one of the other literals. I think we'll do that. Yes. And then this will be more than one of these. Yep, looks good to me. An octoliteral, I suppose we can do octoliteral now as well. It's just the same pattern after all. It'll be 0, 0, followed by 0 to 7 plus. And finally, a binary literal. Binary literal begins with a 0b, and then it's just 0 or 1. Repeated. Okay, this makes me happy. You know, there's really no reason why we couldn't also have octal float literals and binary octal literals. It would make it really, really convenient to define an exact floating point number if you had a binary literal. Huh. I'm going to think about that. That seems like it would be really useful. If nothing else, it would be really good for language completeness. Now, a floating point literal, unfortunately, there's like at least 3 different ways that you can create a floating point literal. So we're going to leave that off for the next episode. I think that we've hit on a ton of things in this episode with creating the rules for an expression. So to not overload ourselves and also to give my throat a rest, I think we're going to leave things off here for today. So we'll come back next time and we'll continue with defining our float literals, float literal, hex float literal, and also our string literal rules. And then we should be in a really good place to actually go ahead and implement these rules in our parsers. So thank you so much for watching. If you have any thoughts, comments, insights, or suggestions, please put them in the comment section and I will get to them when I get to them. But until next time, take care.